So I'm sharing my screen. I hope it's visible. We'll start in a few more minutes until one more people join in. I will do week 6 today. Um, so yeah, so we'll discuss the concepts on week 6 first and some of the problems after that. And that will be our topic for today. So we'll start with Enquine's problem and sort of go to global scope and nested functions, all those. So we'll start with lecture 2 for first because it would be easier to start with that and then we'll go to backtracking endpoints. And then we will go towards permutations and other problems in the other lectures. So we'll pick up few examples, I think, coding examples, so as to give you broad understanding of what the topics are about, and also um, it will give you an idea of sort of like what sort of programming questions you can expect. So, yeah. Okay. So, yeah, we'll start in a few minutes and then we will like that. So I was on mute. So just to a new journey for journey in. So today the plan is to work on week 6, as you can see my screen. So we'll discuss about the following problems for today on backtracking, global scope, nested functions, stacks, queues, and priority queues and hooks. And we'll go through each of these concepts like last times how we did, and as well as we'll solve problems side by side on assignments of pages given the time that we have. And that's our plan. So we're still waiting for more people to join. So I think we'll start in a few more minutes. So Okay, I think we can start now. We have a fair number of people who have joined it, so we can start. So yeah, so for new journers, again once just to give a highlight of what we will be discussing today. So today is week 6. So we will discuss about backtracking, global scope and nested functions, and the following other topics today. We'll go through them one by one, as well as also uh, uh, solve some of the quiz problems and assignments. We'll start with this thing of about global scope and nested functions. Just to and then we'll go to backtracking and quiz problem because some portions you can sort of utilize in lecture one also. So what is global scope and nested functions? So we'll discuss that. So I think uh, last week we had discussed about some portions of like we used global scope nested functions before also in last week's class. But I will just briefly go through one more time in terms of what they mean and like how you can use them in your code. And so basically, some of the quiz problems can actually be also be sort of formulated based upon this kind of problems. So we'll discuss similar problems for that also. So let's start with that. Let me know if you're able to see. So actually, um, I'll just share my this screen. I hope you're able to see. Just let me know if you're not able to see my screen in the chat so that I'll have it. Okay, so we'll discuss about like sort of the scope of a variable, sort of, and then we'll discuss about scope of a function. If you remember, like we had, I think, in the initial first week or something, we discussed about sort of like about scope of a variable, like on a very like loose kind of definition. But now we'll dig into a bit deeper about the notations. So let's say I define a function here. As you can see, there is an example here where I have a variable x equal to 300, and I print that variable, and what I do is like I then sort of make a call to that function. So as you know, like it will just print me the value 100 in this case um, uh, because obviously that's my function flow in my function, and I'm assigning x to 300 inside the function. So this variable x, it's called a local variable. Local. What do you mean by local? Local basically means it's local to the function. Local to the function my func in this case. So because I can only access the variable x from inside the function. I can't access the variable x from outside. So for example, here let's say I had my func. I'm just making a call to the function, but if I sort of write, let's say, print x after this line, then I would get an undefined error because I haven't defined x anywhere. So that's why it's called a local scope variable. And likewise, we can also have something called local functions. Also, you can think of as in a similar context. We'll discuss like how that works. So for example, I'm showing you the example of the same thing. I hope you are able to see my code sort of code editor sort of. So if you run this thing, obviously you get a 300 output. And if I make changes here, let's say I now make changes to 500, let's say, you would get 500 as your output. So now let's say I do this thing, print of x. Let's say I would get a undefined error that says that x is undefined. So if I do this, let's see. So it will give me an undefined error like name x is not defined. Why? Because this x variable, although it's already used in this thing, but it's local to the variable function, my function. So I can't actually access x out this particular x outside of the function. So it's a uh, local variable to that function. So it's called scope. It's called local scope to that function. So it's in the local vicinity of that function. So now we'll go to the other definition which is function inside function, and then we go into global scopes. So similarly, what I did here, as you can see, I had a local variable defined x equal to 300, and then I made a call to the function myfunc, and then it printed me 300. Similarly, like that, what I do have now is I have the same thing x equal to 300, but I define a new function. You can see the def keyword, definition keyword I'm using here. Def my inner function, and then within that I'm doing print of x, and then I'm making a call my inner function. So this function is a nested function of the outer function, which is my function. So I'll just go back to the code editor now. I hope you're able to see. So there, what we are doing here is basically this. So this is my uh, outer function, and the one below it is a nested function, which is a nested function. So this is a local scope variable to my func as a function, and this is I'm making a reference sort of to the case of uh, yeah, so I'm making a reference to the case of to the case of x here, which is print x, if you can see. So this is a reference to the local scope variable, which is x equal to 300, local to the my function thing. So this thing I'm making a call to um, my local scope. Yeah, so that's the kind of idea here. So now, yeah, so let's run this thing and see what we get. We'll say, get a 300 value in this. So this is 300. So let's say now I make this change, print x plus 10, let's say. I would get 310 as my answer. So as you can see, I'm making change to the local scope variable here, and it is resulting in a change value, because this is the sort of because I'm changing the value, which is local to the outside external function, but it's not local to my inner function. So I can always access this x, this x from the my inner function. So that's the reason why I can access that, because x is not a local scope variable of my inner function. X is a local scope variable of my function. So there is this concept of global scope that would come in now. So we should we'll see in some time soon. So I'll briefly discuss. So I hope you got the definition of nested function. So basically, you define a function inside another function, which is something called as nested function. So now going back to the definition once more. So my func, uh, my inner func is actually a nested function of the external function my function, and so on. And you just make a call inside a function itself. So that's why it's called nested functions or function inside function. Now we'll go to something called global scope. How do we do it? So we have local scope. What is global scope? So variables that are created in the main body of Python code. That means under the main function. So, or you can think of it as the uh, without inside any functions. Just in the main program file only. Uh, those variables can be accessed those variables can be accessed through any other values inside the Python program. So those are called global scope. So for example, in this example, x equal to 300, you can see like that x is like a global variable. So you can know like it's kind of it can be accessed by this function. That's a my function, and because within my function I'm actually using x, as you can see, so it can be accessed by my function, as well as if I want to print the value of x directly, I can also do that. So this is like a global variable or a global scope, I would say. So these are the two sort of examples. So other thing you can also think of, there is this concept called global keyword. For example, if you need to create a global variable, but you are sort of stuck in the local scope, what you can do is you can use a global keyword sort of. So for example, originally x was actually a local variable because it was defined inside my function, but now it's if I do a sort of global keyword, that means I can access x outside of the my function. For example, here let's say um, uh, x equal to 300. My function, when I make a call, I can access obviously because x is a originally was a local variable to my function, but since now it's global, when I do print x, I can easily access it. Previously, if you remember, we are getting an error that said x is not defined, but now it won't throw me an error, so I can just run this code with you and just to make a test. So um, yeah, so as you can see, like it's a global variable, and when you print it, it gets a value of the corresponding item. So, so I hope that's understandable in terms of global variables, local variables, and nested functions, how things work. So, if you have any questions here, feel free to ask. Again. Then we can move ahead with the next few questions. Um, yeah, any questions here? You can come. Yeah, any questions in the chat? Like any questions from you? Okay. Yeah. So I think this is pretty easy. I mean, in terms of the concept of what I was mentioning. So maybe we could test out some problems for that. So that I think it can give you an idea sort of the final exam questions you can think of from this topic. So let's do that. So- Yeah, so there is a question in the chat. So, like global local keyword is also available. Yes. So, like you don't need a local keyword because if you are like if you are defining any variable within a function, by default it's a local thing. So you don't need to explicitly define it as local. It's the other way around. We actually need because that's the we need access to, let's say, a local variable. Then we need to make it a global sort of variable. But the other way, people don't use it because by default, any variable that you define inside a function is always a local variable to that function, and you can't access outside of it. So yeah, but you definitely use it. So for example, this is uh, there is like another keyword you can use. So it's not part of the syllabus, I guess, but you can. This is called non-local keyword. Basically, what it means is, um, so for example, if you want to work with variables inside nested function, let's say. So, for example, x is equal to jane and x is equal to hello. So when I define it as non-local hello, in x, let's say. So, and when I set it to x equal to hello, would I would have the corresponding x is equal to jane only because I have defined it as non-local. So basically, it means that it is useful in the case where you want to work with variables that belongs to object functions. So in those cases. So let's get back to some of the questions. I think I hope you will be able to go through them. Let me share that. I hope you are able to see my screen. Um, yeah. So what do you think? Like is from the four of them, what do you think is the correct option? You can answer in the chat if you want. Yeah, so there are responses from the chat. Let's see through. Okay. So which of the following is true about local variables? Obviously, it's accessible only in that function. Accessible in all functions, obviously, it's not. Accessible throughout the program, not. Accessible only in several functions. C is the correct answer here. So, um, so this is just we are starting with an easy problem just to see if everyone is sort of um, able to get through. So now the second question: which of the following is not the scope of a variable? Like enclosed, global, built-in, or derived? So I think this is a bit outside, I think, what we discussed. But anyways, if you know the thing, I mean, might be some questions like which might test something outside. So yeah, it's enclosed because global, built-in, and derived are anyways sort of standard scopes. Uh, so I think we also have object-oriented programming in Python. So I think those things, some of the cases would actually come up there also. So I think it's derived. So let's see this ones. I think can't actually change the answer. I guess. Okay. Anyways, like I will probably go ahead with the next question. So question three. So name equal to Python, and then you have definition function where name is equal to Python. What do you think would be the correct answer in this case? Um, um, so basically, it would be. I mean, you can uh, eliminate options here. You know which options will work, which options won't work. Um, so print name. So okay. So the question is Python Bricks. So I think Abdul says Python Bricks. Other mostly says Python only. Uh, right. It will be just Python only because why is Python? Because you are not making a call to the function. You are just defining the function here and not making the call. So that's why this thing is doesn't get modified. So you just have a main equal to Python only. So that's the correct option. Yeah, I think a lot of people have answered the correct options. So that's a good. Um, right. So if we had the function call after this, after like this function, then you would get Python bits because it would, the name would get modified. So that's the sort of crux. That's it. Okay. So now going to the next question. Um, so which of the following is a built-in variable? Sorry. So is true a built-in variable in a built-in variable, float or print? Would be which of the things are using as a built-in variable? Someone said print. Any other anyone wants to try any other options? Print is a built-in variable. So is print a variable or do you think it's a function? Um, so because print is actually make a function call, right? So so yeah. So what do you think? Yeah. So print is a built-in function, but we actually want a built-in variable definition. So it's true in Python a built-in variable function. It's a Boolean variable. But do you think it's a built-in? Okay, let's maybe. try out. I think I'll go with two. Let's say two. I guess. Sorry. This one, I think. Yeah. So this was the question. Let's see. Okay, so N is a British variable. So I think how many people have answered them? Yeah, it's Boolean is a data type, so that's why it's not a variable. So that's the reason why it's sort of N is the only built-in variable. So and float NUS is print is a built-in function. That's why it's not a variable. So okay, so let's check this next question. So n equal to 4. I define n equal to define function 1 is equal to n equal to you have to. So if you know this operator, what does it do? I guess you know this, but if you don't know, like it just let's first guess the answers and like based upon what you know, then I think I'll come to the debugging. So you just do n equal to this thing and you print n and you make a function call. So what do you think would be the correct answer? So Bharat says error. Okay. Anyone else wants to go? So, then I think I can give you the definition for this. So this basically means it's n to the power 4. So n star 4 basically means n to the power 4. So if in that setting, what do you think it's there are answers like 2 to 6. So let's see this. I think 2 to 6 is the correct answer, but it gives still an error. Why this error? Because I'm actually assigning sort of uh, someone joining. Yeah, so I'm getting an error instead of getting 286. So why do you think we are getting an error here? Anyone has any guesses? So one person said like within the function there is no declaration of okay, yeah, that's true. Because not defining um, um, n to be yeah, yes, because n is global and you are not sort of declaring inside the function f1, so that's why you are getting an error. Such. So okay, so nice. So I think we'll just probably do one question, sort of like question, last question. I think on global thing, and then I think we'll skip to the next topic. So for this question, so where do we are having this kind of structure? Uh, Definition of function n1 equal to 4.5. Function 2 is the following. And this is a nested function because you are doing a function definition within another function. So what do you think would be a final value of n here? So yeah, so there is response that says 6 as the answer. Anyone else want to try? Okay. Uh, so yeah, so I think 6 would be sort of answer here. So let me just check this. But no, 6 is not the answer. Why is it? Why is that? Because I think everyone I think responded 6 as the answer in the chat. So why do you think it's going wrong? So so basically you're defining a global variable n equal to 6, and then function 2 gets called within function 1. So when in the original thing, when you do function 1, right? So you are making a call to n equal to 4.5. So you are assigning n equal to 4.5 there, and then you are doing going to function 2, but you are making the call here, function 2, and within that you are doing n equal to 3.2. So basically this thing, um, for function 1, after this line, your n values gets inserted to 3.2, and so that is the final value that you should get, not n equal to 6, because you're defining it as a global function, global keyword here. That's it. I hope that answers the question. Okay, I think let's get back to the original problem now, and original sort of lecture things now. So, any questions till now on the global scope or nested functions? Any doubts or anything? Please share in the chat. And yeah. Okay, so this was the last question also. So going back once to the last question. So basically, what is happening here is that I'm first calling function one here. So function one, I'm setting n equal to 4.5, and NEC was actually a global variable. So now the value of n becomes 4.5. After this, I make a call to function two. The function two, when I make a call, I invoke this entire thing. Where inside n is equal to set to 3.2 now. And so because n is a global variable in all the cases, that's why as a when I'm accessing print n here, it accesses the global variable n. So whatever changes in the global variable has happened till now, it would get reflected. So the last change is n equal to 3.2, and that's why there's no correct answer that I get 3.2. Okay. Yeah, so let's get back to the problem things. So let's go back to the twins problem, the friendly twins, and I think that with that we can sort of like discuss a bit more on how to do backtracking and all. So okay, I hope you're able to see my screen. This is a classic n queens problem. So I'll just briefly go through. I think many of you might already know, but just to set the context, what the n queens problem is. So it's the following. So the idea is that on a chessboard, how can n queens be placed on an n cross n chessboard so that no two of them can attack each other. So for example, n equal to 4, that means it's a 4 cross 4 chessboard. One possible solution to the n queens problem is the following. So what do I mean by no queens, no two of the queens can attack each other? Basically, that means that no two queens are on the same row or on the same column of the diagonal along the diagonals. So in this setup, as you can see, no two of the queens are on the same diagonal or the same row or same column, and that's why it's a this is a situation we want such that they can no two of them can attack each other. So the question is like how can n queens be placed on this n person chessboard so that no two of them attack each other? And uh, basically this is like a constant programming problem or a combinatorial problem to be precise. And so there are multiple ways to solve this. I think one of them is backtracking actually. So we'll just discuss through that and in Python how you can do this. So yeah, so I think people are still joining. Okay, so right. So So basically, a combinatorial solver, a city solver, works. How it works is by systematically tries all possible assignments of the values to the variables in the problem, and it finds the feasible solutions. Feasible, what feasible means basically is the ones where the constants are satisfied. So in the case of four n queens or four queens problem in this case, the solver starts at the leftmost column and successively places one queen in each column at a location that is not attacked by any previous be placed queens. So basically, you can think of like this. So you place any of the queens on the leftmost column, and then you go to the rightmost, the second column, and you place it such that it doesn't get attacked by the last queen that was placed. And then you go to the third column and you place it such that it doesn't get attacked by the last two queens you have placed, and so on. So that's the basic setup that we have here. So, how do you do this? So there are two keys elements to such a constant programming search. One is that you have something called propagation. So each time the solver assigns a value to the variable, the constants that we have add restrictions on the possible values of the unassigned variables. Basically, in the example of this, in the four queens column, each time the solver places a queen, it can't place any other queens on the row or on the same row and the same column and the diagonals to the current queen, right? Because that's a constant. We can't do that. We have to place the queens in such a way that no two queens actually attack each other. So once we place a queen at a particular position, we can't place any other queens on the same row and the same column and along the same diagonal. So this is like which we call as propagation. Propagation can speed up the search significantly by reducing the set of variable values that solver must explore. So basically, what it means is that my search space, basically, it's like a search space you can think of, that gets reduced a lot because I am putting additional constants. So now the fundamental part that comes in is called backtracking, and this is part of the lecture also, and we will discuss that and we'll see like how Python you can also code it up. So what is backtracking? So backtracking occurs when either the solver can't assign a value to the next variable due to the constants, or it finds the solution already. So in either case, the solver backtracks. Basically, backtracks basically means that you take steps backwards. It's another sort of way to analyze this keyword. Backtracks means you take steps backwards. So the solver backtracks to a previous stage and changes the value of the variable at that stage to a value that hasn't already been tried. So in the four queens example, this means moving a queen to a new square on the current column. So if I go back to the problem here, so let's say the first queen is placed at the second row, the second queen is placed at the last row, and the third queen is placed at the first row. So now let's say I place instead of placing this at the sort of at the first row, let's say I placed it in the third row. Remember the fourth queen I haven't actually tested out yet. So let's say I kept it in the this third row. And so likewise, you can instead of the current solution that you have, you can place it in different places and see how it affects the solution in the long run. So that's like your backtracking problem. So so if you can see as a visualization, what is done here is basically place the first queen here. So all your rows here are blocked, all your diagonals are blocked. On the there's also a third constant which says that all your rows are also blocked. Now you place your second queen in this thing, and here also all your rows are blocked, all diagonals are blocked, all your corresponding columns are also blocked, and so on. So like this, you can place the queens in such a thing. So yeah, so that's the overall sort of problem. I hope you got the idea of like how to do it. So we can sort of like look at the solution, like how you can solve it. So any questions in the problem setting? Like, yeah, so it's like please have a look through the problem setting once more. I'm sharing that in the chat also, this URL. I think it's be helpful sort of. Yeah, I'm posting the link in the URL. I'll suggest everyone to take some time out now, like at least for 5 minutes. You can sort of take a like, look through the problem a bit more, and understand if we have like, make sure like you understand the problem very well, and then we can go ahead. Like, yeah, so let's take a 5-10 minutes just to read through the problem once. Okay, so I think we have gone through the problem. So, once you like will get through the CP approach to this thing, I think we are good to go to the actual code. Okay, I think we're going to the problem, so I think we can start with the sort of the code here. So, okay, so basically we haven't discussed on so they this actually use something as a library, as you can see here, CP model and all. So I think just we can look at some other code for the same. But as you can see, the code structure, why I wanted to show you this, because there is a class, as you can see, this class definitions in Python or like object-oriented programming that you can. So those kind of things you can do in Python also. So for that, I think we sort of I'm showing you this kind of broadened code, because you can use class-wise programming also. I think we'll discuss that in the next few weeks also, and like how you can use class-wise Python programming. So okay, so let's discuss in another sort of coding sort of way. Um, yeah, so I think I have the. Okay, so as you can see, like what you can do simply is like so- okay. So what you can do in this setting is basically I'll just briefly go through this current code only, but then I think you can basically the most of the code lies in this portion, as well as I think they are creating a different of like using a different library for this, but we anyways will be going from start, so we won't actually focus on that. But just how you can start with the problem setting right up is basically like this: like you initialize your in-cross and chessboard, sort of as let's say we define it as queens as a in-cross as chessboard. It's like a list, a list of lists actually. This is a 2D list, so you can define it like that, and then what you can do is like you do a two for loops. Basically, since it's an in-cross chessboard, so for each of the for loops, you it's like a row. You do a for loop across the row of the in-cross chessboard, and you do a for loop across the columns of the in-cross chessboard. Because at each point of placing a queen, you need to see for all possible ij combinations, like ij combinations of row and column, where you need to place the queen. With that, you also need to ensure three constants. One is that when you are placing at I comma j the I mean queen, you should place it such that it's in the same row with any previous of the queen placed in the same diagonal with any of the queens placed, and it's not in the same column also of the queens placed. So how can we do this? I'm just like maybe I should write it. I think otherwise it may not be clear. So let me open a screen sort of. And I hope you will be able to see that. So yeah, let me share my screen. Okay, I hope you're able to see my screen. Um, so basically, what you do is like you do I comma j. I is your like I is your like row indexer. J is your column indexer. So for each I in range 10 and j in range 0, comma 10. So basically, let's say I assume it's 10 cross 10 chessboard. Let's say 10 cross 10 chessboard. So this is my 10 cross 10 chessboard. So I loop over the over rows here, and I loop over the columns here, right? So this is my sort of the thing. And what I do now is basically I do the following. So if my I check the check if any of the IJR positions are actually feasible to place or not. So I will check this thing. I will, let's say, do feasible. I'll define feasible as a function I comma j. If the cell is check if the cell is feasible or not. So I do board comma I comma j is equal to 1. So I'm defining board is equal to 0. Let's say I initialize the board as a list of list, as you can uh, as you can see from the kind of thing that I've defined in the original code. I think they define queens as the list of list, but we are defining boards as the board as the initial board, sort of 10 cross 10, all initialized to 0 sort of. And so when I place a thing, I do board I comma is equal to 1, and I again make a call to a function called DFS. We'll discuss what it is. And if DFS returns true, I will just return true. Otherwise, I'll just mark the cell as unvisible. So let's define the thing now. So in any of the cases, if sort of um, if no path is found, it's a false thing. So now I'll define feasible here. So what feasible basically means is that um, if so here I would add some conditions. So one condition is that I should not be less than 0 and I should not be greater than 0. That means I'm not going outside of the sort of the box actually. And if my so in that case it should return me false if I go outside. And if I already visited a cell, it's again set to false. Now I add the extra conditions, which is if board of I uh, uh, so if my any of the previous queens are actually in the same column, same rows and all, so I can't add that in that I comma j position. So I'll just do for all for example I can vary j for k value where k is you can again do a for loop, let's say where k equal to 1 2 3 4 up to 9. So that indicates for all columns whether I have placed 1 or not. So if this is equal to 1, I would have to return false again. Similarly, you do it for the row thing, where row is like you do board I plus for all I plus 1, I plus 2, I plus 3, I plus 4, up to I plus 4, 9. You do the same thing and you say if this is the case, and you do the same for the diagonal also, where you do I plus 1, I plus 2, as well as j plus 1, j plus 2 at the same time. So in any of the case, if this is true, you just say like, okay, the position I comma j is feasible to place my queen. So I would go ahead. And so what DFS I comma j does is basically it's like the backtracking thing that we're doing. So board is like the sort of the propagation part that we were discussing. So this DFS is like my sort of my backtracking thing. In backtracking, what I would do is like if it should give me like something like, let's say, let me define it. So it should give me something like uh, if my move is actually feasible. So, for example, I loop over all possible moves here, k equal to 1 to 9, and I check like if my move is feasible, I use that board cell. Otherwise, I would backtrack to the previous position where I already was, and I try for other possible problems. So, this is just a rough pseudocode I have provided here, but you can modify it a bit more to make sure the all the constants are handled. So I hope that answers. So we can get back to the screen here. So yeah, I hope that answers the question. Okay, so yeah, any questions in the definition, column definition, or anything? Okay. Okay, so let us go towards the other next lecture topic, I think, which was on um, set stacks and queues. I think we already covered some portion of sets, I think, but let's actually look at some more and sort of discuss about it. So probably I think the people might have already gone through the lecture. I think we probably going to start with the quiz, some of quiz problems on sets and all, so that gives people some understanding of what sort of questions can be asked. Okay, let me go through the quiz examples here. Which of the following is not true about set? Uh, does it enclose elements using curly bracket? Is it mutable? Is this hash tables? What do you think is not true about the set definition? Yeah, anyone has any uh, guess what would be the correct answer? Okay, so yeah, so let's see. This is none of the above is the correct one because sets are mutable anyways. And you can use this hash tables also, and it obviously encloses elements within curly brackets. Let's get to the next one. So, what do you think is the correct way to declare an empty set? Okay. There are some responses. Let's see. Um, so option two, option two, option two. Um, yeah, the first option is like a big, so that's why you can do. Okay, but yeah, so uh, this is not a dict actually because you can define it as dict as a define. So this would be upward option A and B. So instead of just having BM because for dict, I think for dictionary also you can do it in similar way. Set also you can do in a similar way because how you define the elements within it is something different because you can have nested dictionaries also. So that's why. Okay, so which of the following is an extra property of a quotient set? Is it immutable, can access values using index, have more number of detailed things, operators, all of that. What do you think is the correct option here? Option 4 is one person after the option 4. Anyone else? Okay, I think, yeah, please share the responses here for this question. We probably can take a 10 minute sort of break, sort of, I think, because it's almost in the middle of the lecture now. So it's a 2 hour lecture. We can take a middle 10 minutes break. We will resume once we are at 4:16, so that others can actually also like form any questions if they have doubts on anything. So we'll resume again in 10 minutes. We'll start again in 10 minutes with this question. Okay, so we'll start like that. Okay, we'll go through this problem on the on now. I think I hope this thing you are able to see. It's immutable because it's a frozen subject. It's not deep. So yeah, so let me go to the last few topics for today for week six. For lecture six, one was on priority queues and heaps. We'll discuss on heaps first. Let's say, okay, let's say. So what are heaps actually? So heaps are basically like concrete data structures, whereas in priority queues, just okay, not sharing the screen properly. So yeah, so heaps are concrete data structures, whereas priority queues are like abstract data structures. The abstract data structure determines the interface, while a concrete data structure defines the implementation sort of. So, where do you use hips mostly? So, hips are mostly used to implement something called priority queues. We'll discuss priority queues side by side with this. So, these are like one of the most popular choices of data structure for implementing priority queue abstract data structures. So, the following are like the sort of like functions in hips or priority queues. One is like isempty, add element, and pop element. So isempty checks whether or not my key is empty or not. Add element checks if I can add some specific element to the key. Pop element means whether I can pop the element with the highest with the priority. I can pop up the element. For example, how do I define such thing called priority? Why it's called priority? You. So priority can be judged by two different things. One is the largest element, let's say, has the highest priority. Let's say that is one. Or the other case can be smallest element has the smallest priority. So these are like kind of the possible ranges of priority that we have. So so there are two conventions that are equivalent because you can always reverse the other priorities. For example, smallest element can be reversed into largest element by just reversing the distance. For example, if you have elements consisting of numbers, then using negative numbers will actually flip the conventions, obviously. So the Python has its own module which is called heap PQ, which is like a priority queue which is used for heap data structure. This is the second convention, which is the smallest element uses the highest priority, and this is generally more common sort of. So under this convention, the smallest element obviously has the highest priority, and this might sound kind of surprising because in real life examples you will see this kind of convention where you have the smallest elements as the highest priority would actually, in many cases, tunes you into the original problem statement. So so the heap implementation of priority queue guarantees that both pushing, that means adding a new element, and popping removal elements are logarithm time operations. So this means that the time to take taken to push and pop is proportional to base 2 logarithm of the number of elements. So as you know that as compared to linear functions, logarithm functions grow slowly. So the base 2 logarithm of 15, for example, as an example, it's about 4, while base 2 logarithm of a trillion is about 40. So as you can see, logarithms grow slowly. So this means that if an algorithm is fast enough on 15 elements, then it's going to be only 10 times slower on a trillion elements, and will probably be fast enough as you can see the difference in numbers. So in any discussion of performance, the biggest caveat in this settings are actually that they are less meaningful than actually measuring a concrete program and actually trying to figure out what the bottlenecks are sort of in these cases. So let's actually look at the heap data structure first, and then I think we can go to the priority queues on it. So a heap implements a priority queue as a complete binary tree. I hope everyone is here is almost knows about binary trees and all. So in a binary tree, each node will have at most two children, and in a complete binary tree, all the levels except possibly the deepest one are full at all times. So that means the you can, for example, this is like a complete binary tree because at each levels you have at max two branches, all are full. So you have a complete binary tree. So the completeness property means that the depth of the tree is the base 2 logarithm of the number of elements on the top. So, for example, the depth of this tree is equal to 3 because I have 8 elements and log this base 2 log of 8 is actually equal to 3. So, in the particular example here, all levels are complete. So, at each level, as you can see, are a complete sort of each node except the for the deepest ones. Deepest ones are basically 5, 6, 7, and 8. Each of them, except the deepest ones, are actually having all children towards them. Yeah, so I think binary tree is in next week. I think I'm sort of like having everything in one place. I don't know because Hips actually uses that, but we'll revisit that once more. But just for giving a brief outline sort of how the Hips are implemented. So, okay, so the single node at the base level is called the root node. As you can see, one is the root node, and it may kind of seem weird to call this as the top of the tree because obviously tree, if you visualize it, tree is like the branches go out at the top, not downwards. But this is like a common convention in in the computer science field where you have downward pointing trees as called as tree. So the performance guarantees in a heap are actually on how many elements sort of kind of percolate up and down in the heap. And the practical result is that the number of competitions in such a heap sort of thing is based on logarithm of the size of the heap. So remember, we also discussed sometime back about heap sort also. I think so. This is very much sort of how heap sort also works, like this kind of strategies. Okay, so I think let's actually dive into the priority key first, and then we'll see about the heap thing. So priority key is like under heap as an implementation of the priority key is useful for programs that involve finding an element that is extreme in some kind of way. For example, you can use a priority key for one of the following tasks. Let's say given three most popular blog posts from some data, find the fastest ways to get from one. So this is one example. Like uh, get me three most popular blog posts. So as you can see, it's like a priority here. Like most popular is like a priority here. And then the other example can be finding the fastest way to get from one point to another. And another example can be predicting which bus will arrive to the first to arrive at a station based on arrival frequency. So this kind of problems you can think. So let's actually sort of look at some more details. Um, okay, so although you saw the heap described earlier as a tree, it is important to remember that it's again a complete binary tree. So completeness means that it's always possible to tell how many elements are there at each layer except the last one. Because of this, heaps you can implement it as a list actually, and this is what the Python heap queue model actually does. So there are three rules to determine that. If the first child is at 2k plus 1, second child is 2k plus 2, and the parent is at k minus 1. So that's how you place the nodes in the list. Basically, for example, if I go back to the tree example here, if you want to convert this into a Python list, you will be you place one in the first position, two and three should be placed at 2k plus 1 and 2k plus 2. So k is basically the index of the parent element. So since k is equal to 0 for 1, so 2k plus 1 is basically 1 only, and 2k plus 2 is equal to 2. So 2 and 3. For the children of 2, 5, and 6, so 2 is placed at index 1, right? So I would place the children of 2 at 2k plus 1 and 2k plus 2, which is basically 3 and 4. So I would place 5 at index 3 and 6 at index 4. And similarly, I will do the same for the node 3 and its corresponding childs. So that's the basic idea. So its first child is at 2k plus 1 and second child goes at 2k plus 2. And let's say I have a child at position k, let's say index k, then I can easily determine that the parent is at position k minus 1 divided by 2. So I hope this is kind of self-explanatory how you can go from one position to another. So I just actually, so this is like the sort of positioning of element in the Python list. So one and then two, three, then five, six, and then eight, seven. So like so any I hope this is a bit clear. I think we'll discuss about trees, I think, in the next week. So this is like a brief kind of thing. So yeah, so for example, I have pop function as a thing. As I was mentioning, pop and push are two priority queue examples. So for let's say I have list as follows. I do push a comma 4. It would push the element at the last position, which is 4. And if I do a pop, it would give me out the smallest value element, which is 2 in this case. And next I do pop again, it will give me 3. And next I do pop again, it will give me 4. So pop would actually give me the element with the highest priority as the thing. In my case, highest priority is basically the smallest element. So that's why it gives me, you can see the smallest element as you can see. Okay. So I hope there are no questions here. So I guess so problems you can sort of use heaps to solve. So heaps are good for incrementally merging sorted sequence. As I mentioned, like in terms of heap sort and all these things, you would see utilization of heaps as a data structure. And for example, these are the sort of like the top keywords that you should look for when you want to use heap as a data structure. One is like largest, smallest, biggest, smallest, and low. Like this, basically, prior anywhere that you have priorities as a sort of a metric in a problem setting, you use heaps and priority queues there. So whenever a problem statement indicates that you are looking for some extreme element, it's a worthwhile to think how about using a priority queue in these situations. So those are the basic operations in HIPs and priority queues and HIPs. I hope that explains. But again, I will just show you another documentation here. For example, the main operations of a queue sort of. So what is a queue? Let's say a queue is like a linear data structure that follows. I think the people who have taken data structure algorithm courses probably know this. So queue is like a linear data structure that follows a first in first out principle. That means first element added to the queue is the first one to be removed. This analogous to a physical queue of people waiting in line. The first person in the line is the first to be served. So there are these are the operations. NQ is basically adding an element to the end of the queue. DQ is basically remove an element from the front of the queue. Is empty is basically check if the queue is actually empty. This one is basically check if the queue is full and so on. So these are kind of the operations you need. So where are we using something like queues or priority queues? So as I mentioned, like some examples I already gave. Some can be like job scheduling, like tasks to get added to a queue and processed in order. You have pins, coolers also. I think mostly in computer organization, these things actually are implemented. So for example, pin jobs gets pulled into a queue before being printed, and keyboard buffer and all these things. So so basically queue implementation in Python, you can do it in the following settings: a P4 queue or a LIFO queue, a stack. LIFO queue is basically stack is another form of queue. So stack is also another data structure. Um, and the third one is priority queue, which is basically the topic course topic for today. It is the elements based on some priority. So these are like um, some of the sort of like Python inbuilt queue data structures. So queue is equal to queue I'm initializing, and then are the following sort of operators that I can use. And for example, I do the same. The queue put a one basically adds one to queue. Queue put two adds two to the following, and so on. So I'll just directly go to priority queue. So in Python also you have priority queue inbuilt. So it's actually comes from hip queue only. So priority queue is this thing we put at position 3C and so on. So this is like a tuple sort of you are pushing inside queue. So these are the kind of operations. So okay, so I hope that sort of discusses some of the concepts here. I any questions so far? I think probably end this now. I think to this lecture, I think we'll set up. I'll just post this links I think in the chat. I think we will actually will mention. I'll just post this links. Yeah, please go through them. I think this should also help you to. Okay, I think if there are no questions, I think probably we can end the call today. We'll meet again next week. So this is week 6 lecture. I will post some of the lecture series. So the one question in the chat, I will end the call with that question. So what is breadth first search? Yeah, so there are two cases. One is depth first search and one is breadth first search. So if I go back to the one of the uh, one of the diagrams in the tree structure, the breadth first search basically means that I'm actually searching across the breadth only. So meaning like from one I go to two, then I go to three, and if I want any other branch I go to that. But so I'm at each point I'm actually checking all the branches only first, and then I'm going to the next children's. So that's my breadth first search. Depth first search basically means I pick any one of the branch, I go to the corresponding node for that, and then I again repeat the same. I only sort of explore in a particular branch. That means I only go to the node is corresponding children, then is corresponding children, and so on. So it's like a depth first search. In the breadth first search is basically I'm actually checking first all the branches first, all the children in my immediate branch, and then I go to the children of those children, like that. So that's your breadth first search. Okay, I think I hope that answers your doubt. We'll end the call today. There are no other questions, and we'll meet again next week, same time. And thanks again for joining. Yeah.